Hi everybody, my name is Nicholas Monroe. I'm an application scientist here at Micromortics, the world's leading supplier of instrumentation for characterizing powders, particles, and porous materials. Today, we're going to be taking a look at the FT4 Powder Rheometer to see how it can be used to gather accurate and reliable powder flow data. First, we'll take a look at the instrument and start the first test we're going to be using to characterize powder flow. This first test is going to be stability and variable flow rate. I'll go into the details of this test, what it measures, and how to perform it. On the software, I will select standard test programs, then select stability and variable flow rate. Next, we will select the vessel size. The FT4 has 3 different vessel size options to accommodate for different particle sizes and amounts of sample available. In this example, I'll be using the 50mm diameter vessel, so I'll select that. At this point, the software will prompt me to install the correct accessories and vessels for this experiment. So I will install the 48mm blade, as well as the 50mm diameter 120ml volume split vessel. Now that the correct accessories are installed, I can tick both boxes and continue on to the next screen. At this point, the software is going to tear the empty vessel, so I will wait for the mass recording to stabilize and then click tear. Here I have some example material I will load into the vessel. You need to add enough powder so that it goes above the split level in the vessel. I'll quickly brush off any excess material that got stuck onto the funnel. Next, I'll make sure the safety shield is down. Once the mass reading stabilizes, I can record the sample mass. I will then be greeted by a data label screen where I can input any information about the material that I am testing. For this demonstration, I'll write example material, and then I can click Start Test. In the stability and variable flow rate test, we're going to be running through multiple cycles of conditioning and testing the powder in order to characterize its flowability as it undergoes repeated test cycles in the FT4. This test sequence will begin with one conditioning step, which is meant to homogenize the powder and give us a loosely packed, repeatable initial condition for the powder's packing. Now that the initial conditioning cycle is complete, I will open the safety shield and brush off any excess powder that was stuck onto the blade before splitting the top half of the vessel open, removing any excess powder. I've now isolated a 160ml powder sample. I will then return the vessel back to its closed position and close the safety shield before clicking OK to continue with the rest of the test. By repeating multiple cycles of conditioning and testing the powder, we are going to characterize the powder's sensitivity to being tested in the FT4 and measure how its flow properties will change under those repeated test cycles. Doing so can help characterize certain powder processing phenomena such as segregation, deaeration, agglomeration, or attrition. The main flow parameter that we gather from this experiment is the basic flow energy. This characterizes the powder's resistance to the blade's downwards traversal under a set path at a fixed tip speed, which then implies the powder's resistance to flow within a constrained environment. Another parameter that we can gather from this experiment is the powder's specific energy. This is the resistance of the blade's upwards traversal through the powder bed and thus reflects the powder's flowability in an unconfined space. I'll also note that this is only a single experiment that can be performed with the FT4. The FT4 offers various different options for analyzing powders, with tests such as aeration, consolidation, permeability, compressibility, shear cell, and wall friction analysis. One of these additional tests we can perform with the FT4 is the aeration test. This test will use the aeration control unit as well as a special vented base which connects to the ACU. Additionally, we have different spindle accessories such as the vented piston, which we will use for compacting the powder, the shear cell head, which we will use to perform shear testing and characterize particle-to-particle interactions under a high-stress environment, and the wall friction disc, which we will use to characterize the frictional interaction between the particles and the equipment wall. During this section of the test, we're doing the same thing as in the stability section, running repeat cycles of conditioning and testing. Only now we are adjusting the tip speed of the blade to understand how the powder's flowability will change at different flow rates. Here's a dataset that explains the various tests that can be performed with the FT4. The first plot I'm showing here is for the stability and variable flow rate test, which we just saw in action a moment ago. This graph compares the two different batches' basic flowability energies across repeated test cycles and at various tip speeds. Here we can see that sample B generated a higher BFE, indicating that it has increased resistance to dynamic flow. We can also use the data analysis software to generate index graphs for each of the different powder flow parameters that are measured in this test. In contrast to these samples' BFE trends, we can see that sample A generated a higher specific energy value, suggesting that this sample has increased mechanical interlocking between the particles. We can also see that the two samples display differing behaviors in response to the changing tip speeds, with sample B generating a flow rate index below unity. This suggests that the two samples would behave differently in blending or mixing applications. Both samples were shown to be physically robust, with stability indices near unity. Lastly, we can compare these two samples based on their conditioned bulk densities. Here, sample A was shown to generate a lower CBD value, suggesting it may have decreased particle packing efficiency. We can also compare these samples over a wide range of other experiments done on the FT4. For example, the aeration data shown here indicate that sample A was less sensitive to aeration, suggesting that it has stronger cohesive interactions. We can also look at the bulk properties to compare these two powders in terms of their compressibilities, as shown here. We can see here that sample A was more compressible. These results, along with its decreased CBD, further indicate that this material has less efficient particle packing structure. Additionally, we can look at the air pressure drop values during a permeability test to characterize how easily entrained air can escape from each sample. In this example, we see that sample A yielded a much higher pressure drop, indicating it is a much less permeable powder compared to sample B. Ease of air transmission can be beneficial for various applications such as container filling or hopper discharge, but detrimental to other applications such as pneumatic conveyance or dry powder inhalers. Next, we can look at the shear properties of the powder in either a shear cell or a wall friction test. We can see here two different yield loci that were formed for the different samples. These differing trends indicate that the samples will exhibit differing behavior within a high-stress environment, such as in a hopper. The higher shear stress values generated for sample A suggest that this sample is more resistant to the onset of flow within a consolidated environment. These results are in agreement with the increased specific energy that was observed for this sample in dynamic testing. Lastly, we can look at a wall friction test where we are characterizing the two different batches in terms of their ability to flow along a stainless steel disc. The main parameter that comes from this test is a sample's wall friction angle. Here, sample A generated a higher wall friction angle, suggesting that it has greater resistance to flow across the stainless steel equipment walls. Thank you for joining me in today's demonstration of how to use the FT4 Powder Rheometer to gather accurate and reliable powder flow characterization data. If you have any questions or would like to learn more about the FT4 or any of our other instruments, please visit us at micromeritics.com.